Okay, so we have one last video on chapter 8, and then that will cover everything that you need to know for your My Math Lab. I believe there's 7 or 8 questions in My Math Lab for you. So let me share my screen one last time. So this is what's called conditional probability. So conditional means there's conditions that are set in order to find the probability. So this is the math. So this is the notation that you'll see. So this is the probability of A given that B has already happened. So if you think about a scenario would be, let's say I have a deck of 52 cards, and it includes, spades, hearts, clubs, and diamonds. Well, what's the probability that I'm going to pull a queen given I've already pulled a jack? So that's the idea. It has some conditions set. Something has to have happened first before the second thing can happen. So that's what conditional probability means. The way that we're going to look at it, and again, this is very surfacey. Your statistics class gets much further into this, but we're just going to look at the very basics. And in your case, you're going to be looking at charts. So the formula for conditional probability is the probability of A given B, so A is going to happen after B has already happened, equals the probability of A intersect B, which you guys already know how to do that. It's that intersection, divided by the probability of B. And then the disclaimer is the probability of B cannot be 0 because you cannot have 0 in the denominator. Okay, so when we're looking at these, you're going to be given a chart. Okay, so in My Math Lab, you're going to be given a chart, and it says use the table on the right to find the indicated probability. Events A, B, and C are mutually exclusive. That means there's no overlap. And so are D, E, and F. So when you look at this chart, this column, let me mark it here. This column right here is column A. This is column B, this is column C, and then working the other way, change my color here. This is row D, row E, row F. The totals are at the bottom of each column, and they're at the end of each row. You can see that when you add this last total up, so 0.3, 0.4, and 0.3, you get 1. And when you add these columns up, this bottom row, you also get 1. So remember, probability is always between 0 and 1. When you add up all the probabilities, you should get a total of 1, okay? So with that said, we want to find the probability of B happening, okay? So you come over here and you look at, this is the column, this column right here is all B, right? So you're going to find the probabilities of every single one of these, and they're given to you. You don't have to find them. They're already given to you. So to find the probability of B, anything that is included in B has to be included in our probability. Well, because these are all mutually exclusive, we're just going to add all of these up. Well, they're already done for you, right? The addition's already been done. If you don't trust it, you're going to go 0.02 plus 0.07 plus 0.02, and I'm getting these right from here, 0.2, 0.7, 0.2. And when you add them up, 7 and 2 is 9, plus 2 more is 11, so 0.11. So that right here is the probability that B is going to happen. It's mutually exclusive, so you just add the probabilities up. In this chart, it's already done for you. Simple as that. Okay, this chart, now we're looking for, the probability that B is intersecting D. Well, based on that same idea that we have, columns and we have rows, anytime we're looking for an intersection, we're looking for literally where they meet. So if I'm looking for the probability of B intersecting D, so here's B, here's the column of B. I'm going to circle it. Here is the row D. You can see it. Well, right here, highlight it. Right here is where they intersect. And that's your answer. So the intersection of D and B is at 0.04. Okay, so it's a lot easier than it looks. It looks kind of big and scary. Let's try another one. Let me do another different color to show a different intersection. Okay, let me get the answer here. So this is 0.04. For this one, what if I wanted the probability of A intersect E? Okay, A intersect E. Well, here's the column A. Here's the row E. Right where they intersect, oops, right where they intersect is right here. So that, oops, can't get the right color. That would be 0.41. Okay, so it's literally where the two, think of it like a multiplication table. You know, if you're doing 2 times 3, right, it's where those two numbers meet. It's the same idea. That's the intersection. It's where they intersect. Okay, pretty simple. All right, next thing is independence. So independence is based on multiplying the two probabilities. All right, so if A and B are any events in the sample space, we say that A and B are independent if when you intersect them, if you have an intersection, the probability of the intersection is the same as the probability of both of them multiplied. That's what this is showing. This is showing multiplication. Okay, so if I multiply their probabilities and it is the exact same value as where they intersect, then they are independent events. Okay, in other words, there's no crossover between them. Okay, so the question is, are the events A and D independent? All right, are they independent? Well, the only way we know if they're independent is if their intersection, right? So the intersection of A and D is 0.15. Okay, now what we're going to do is we're going to test that. If I get the probability of A, which is 0.5, and it's right here, that's the total of A, and the probability of D is right here, is 0.3. When I multiply 0.5 times 0.3, I'm going to get 0.15. So you can see these are the same values. Since the intersection is the same as when I multiply them, then yes, A and D are independent. Okay, and so this is we're just repeating exactly what's here, what indicates independence. Okay, and so then I showed it here. Here's the probability of D, or I'm sorry, of A is 0.5. Probability of D is 0.3. When I multiply them, I get 0.5. So yes, they are independent. Okay, so this is another example of something that you will see. You have to fill in a couple of blanks here. So they're asking, is the pair of events A and F independent based on the following table? So the first thing you're going to do is you're going to find the probability of A intersect F. So where are they intersecting? Here's A, here's F. So they intersect right here, right? Here's A, and here's F. So where they intersect. Okay, so you're going to get that value. And then you're going to get that values independently. The probability of A is 0.5. The probability of F is right here, 0.3. When I multiply 0.5, we already did one like this, times 0.3, we get 0.15. Well, 0.18 does not equal 0.15. Okay, so these are dependent. Okay, so what you're going to do is you're going to have to pick from these 4 choices. A and F are dependent because the intersection equals, well, we know they don't equal, so that one's out. A and F are independent. Well, that's out. And A and F are independent. So the only one it can be is this one. And then read it. A and F are dependent because the intersection does not equal multiplying them. And then the intersection was 0.18. And when I multiplied them, I got 0.15. Okay. And that's it. That's the rest of chapter 8. Let me know if you need any help.